where curiosity tucks itself in gently and science pulls up a warm blanket beside you. Tonight, we're tracing the breath of ancient winds and the echo of frozen silence through time as we ask a question buried deep in the bones of our ancestors. How did the Ice Age make us human? Not just cold weather survivors, not just clever apes with mittens and fire, but the species who told stories, painted caves, and eventually sent robots to Mars. How did glaciers and snowstorms, mammoths and miles of ice sculpt our minds, our migrations, our very sense of who we are? It's strange to think about, isn't it? That the shape of your nose, the curve of your thoughts, and maybe even the rhythm of your dreams might be whispered echoes from a world locked in ice. And while we're pondering such chilly wonders, I'd love to know, where are you listening from tonight? Is it warm and summery where you are? Or is there frost creeping quietly across your window? If you find this a gentle companion for your evening, a soft science story to carry you towards sleep, I'd be ever so grateful if you'd give this video a like, or maybe subscribe. It helps this cozy corner reach others who could use a calm voice and a little wonder before bed. Now, I do hope this doesn't keep you awake. But if it does, well, at least you'll know a bit more about ice, extinction, and the deep time origins of humanity before you drift off. So settle in, slow your thoughts, let the room fade just a little at the edges, and let's begin. Because long before cities or calendars, before firelight or lullabies, there was a cold wind across the plains, and in that wind, something new was waiting to awaken. Roughly 2.6 million years ago, something began to shift. Not all at once, not with a bang or a comet, but slowly, a quiet exhale from the Earth itself. Glaciers began to grow, oceans stirred restlessly, and a planet that had been mostly warm, mostly stable, changed, not just once, but again and again. And somehow in this shifting cold, in the middle of extinction and evolution, a peculiar primate learned to thrive. It learned to think, to feel, to adapt. It learned to become us. But how did a planet plunged into ice give rise to the human story? Let's find out. You might not expect it, but some of the biggest clues to our icy origins started with a compass. It was the early 19th century, and mariners had begun to notice something odd. Their compasses didn't always point exactly north. Sometimes the magnetic needle drifted, just a little. Not wildly, not dangerously, but enough to whisper that something beneath the earth was moving. That tiny wobble, that slow twitch in the direction of magnetic north, would eventually lead geophysicists to uncover something far stranger than they imagined. That continents drift, that oceans open and close, and that the entire surface of the Earth is a shifting puzzle of plates riding over molten rock. But even before plate tectonics became textbook knowledge, there were other mysteries, stranger ones still, that pulled scientists into the frozen past. Far from the sea, in the rolling hills of 19th century Europe, farmers had long been turning up boulders in odd places, giant stones perched alone in the middle of meadows, scraped, gouged, sometimes delicately balanced, with no clear reason for being there. There were no mountains nearby, no cliffs for rocks to fall from. Just empty plains, gentle fields, and these strange erratics. Enter a man named Louis Agassiz. A Swiss geologist with a flair for dramatic ideas, Agassiz began to suggest something almost absurd at the time, that these boulders had been dragged by ice. Not just a winter frost or a frozen pond, but by glaciers, gigantic rivers of ice hundreds of meters thick that once flowed across the land like slow, grinding monsters. At first, his colleagues laughed. Europe buried under miles of ice? It sounded like something from a myth, a fever dream. But Agassiz didn't just point to boulders. He pointed to striations in bedrock, parallel grooves carved by the scraping weight of moving ice. He showed valleys, U-shaped, not V-shaped, their geometry rewritten by glaciers instead of rivers. He spoke of moraines and drumlins, eskers and till, and slowly the laughter faded. By the late 1800s, the idea of a great ice age began to take hold. Not a single cold snap, but a series of frozen chapters in Earth's story, what geologists now call the Quaternary glaciation, stretching from about 2.6 million years ago to, well, right now. Because technically, we're still in it. A warm intermission, yes, but the curtains have not quite closed. Since Agassiz, the clues have multiplied. From the deep layers of sediment on the ocean floor, where ancient plankton shells preserve the memory of temperatures past, to the gas bubbles trapped in Antarctic ice, tiny time capsules of the planet's breath, oxygen, carbon dioxide and other gases held still in crystal silence. These paleoclimate records have let scientists reconstruct a timeline not just of one ice age, but many. The Earth, it turns out, pulses. Glaciers advance, glaciers retreat. Sea levels rise and fall like slow heartbeats. Forests give way to tundra, which in turn gives way to desert, only to bloom again. And humanity, our entire species, has emerged and evolved during one of the most dynamic, most dramatic, most climate-battered eras in Earth's history. What triggered it? The answer, like so many things in geology, begins with a quiet tilt. Our planet doesn't spin like a perfectly balanced top. It wobbles, it leans. The Earth's axis tilts at about 23.5 degrees, but that angle shifts over time, rocking back and forth between about 22 and 25 degrees. This change, part of a cycle called obliquity, takes about 41,000 years to complete. But that's not all. There's also precession, the slow turning of Earth's rotational axis, like a spinning top beginning to sway. That takes about 26,000 years. And then there's eccentricity, the shape of Earth's orbit around the Sun, which shifts from more circular to more elliptical over cycles of about 100,000 years. Together, these cycles, known as Milankovitch cycles, after the Serbian mathematician who mapped them in the early 20th century, combine to modulate the planet's climate like a giant celestial dial. When conditions align just right, when northern summers are cool, when snow doesn't melt, when sunlight dims in slow rhythms, ice grows, glaciers expand, and an ice age begins. But orbital changes alone aren't quite enough. Earth has had wobbles and tilts and loops for billions of years, but full-blown glaciations only happen under particular circumstances. Geography matters. The position of the continents, ocean currents, the breath of volcanoes, the slow breathing of carbon dioxide into and out of the atmosphere. By about 3 million years ago, the continents had shifted into a configuration that was just right, or just wrong, depending on your perspective. The Americas had locked together, forming a land bridge between North and South America. This sealed off the flow between the Pacific and Atlantic, reshaping ocean currents and changing the way heat moved around the globe. Antarctica, long isolated, was encased in permanent ice. Greenland had started to freeze, and high in the Arctic, the seasonal sea ice thickened and held its grip. Add to that a steady drawdown of atmospheric CO2, possibly linked to the rise of mountain ranges like the Himalayas and the Rockies, which increased weathering of rocks and locked carbon away. And the stage was set. And so, one winter didn't end. Not fully. The snow that fell didn't melt completely. Year after year it accumulated, compressed, became ice, and began to move. Glaciers flowed south from the poles and from mountaintops, inching across continents. They carved valleys, redirected rivers, crushed forests under their weight. Sea levels dropped by over 100 meters as water was locked into frozen sheets. Whole ecosystems disappeared beneath the ice. But not everything was frozen. Between the great glaciers lay vast steppe tundra, dry and cold but full of life. Mammoths, woolly rhinos, giant ground sloths, saber-toothed cats, short-faced bears, birds, insects, grasses. Life endured, adapted, waited. And among them, scattered at first in Africa, were early hominins, upright apes with clever hands and curious eyes. They didn't know they were living through an ice age. They didn't know their world was wobbling in slow motion, but they felt it. In the shifting rains, in the long droughts, in the cold that came without warning, and slowly, generation by generation, they changed. The pressure of climate is not like a hammer. It doesn't strike all at once. It's more like wind against stone, relentless, subtle, quietly shaping, and it's here, in this tension between ice and adaptation, between loss and ingenuity, that the story of us begins to take its most human form. Before there was firelight in human hands, before names, before memory, there was a world shaped by ice and wind, by silence and slow change. A world ancient, unfamiliar, and yet, somehow, connected to the bones beneath your skin. To understand how the Ice Age made us human, we must first step into the world before it began. A world already old, already alive with stories carved into stone. 2.5 million years ago, the Earth was teetering. Not dramatically, not with eruptions or sudden collapse, but like a seesaw shifting ever so slightly toward a colder balance. The continents were more or less where they are now, though the outlines were different. Africa, the crucible of our kind, pulsed with rhythms of rain and drought. The Sahara, now a vast sea of sand, was then a shifting patchwork of grasslands and wetlands, forests and lakes. Rivers came and went. Animals migrated in loops older than any calendar. Elephants, giraffes, antelopes, lions, and walking among them, upright, curious, uncertain, early humans. They weren't yet us, not fully. But the line was beginning to form. To the north, Europe waited under temperate skies, woodlands, open plains, great herds of deer and bison, bears in the forests, wolves trailing the edges. To the east, Asia stretched wide and wild, rivers fed by mountain glaciers, luous plains swept by dust and snow. And far to the south, Australia was still unpeopled, quiet in its ancient song. The Americas too remained untouched by human feet, though not for long. The planet was readying itself, drawing in breath. But the Ice Age didn't descend like a curtain. It crept. Winters grew longer, summers cooler. Rain patterns shifted. The forests in Africa thinned, giving way to open savannas. Fruit-bearing trees grew scarce. Shade became rarer, and with it, the comfortable refuge of the arboreal life. Some primates stayed in the trees, adapted, vanished, but others climbed down. It's not entirely clear why. Perhaps necessity, perhaps opportunity. But once they did, they began to change. Hands once used for swinging became tools for grasping, legs strengthened for walking upright, eyes turned forward, scanning open ground, and most critically the brain, the slow burning furnace of human evolution, began to grow. This was the world of Australopithecus, and then Homo habilis and Homo erectus. Not modern humans yet, but ancestors walking the same ground, beneath the same sun, with minds opening like flowers toward complexity. They made tools, crude at first, then better. Stones chipped to edges. Simple, yes, but revolutionary. With sharp stones came new food sources, marrow cracked from bones, roots and tubers peeled and pounded, fire not yet tamed but perhaps glimpsed, lightning fires, charcoal, ash, sparks waiting for hands to harness them. And over time, those hands did. Homo erectus was a traveller, the first true wanderer of our line. They left Africa over 1 million years ago, walking into the widening world, into the Caucasus, into Indonesia, China, Europe. Wherever the land allowed, they followed. And behind them came echoes of firelight, stone axes, hearths beside ancient rivers. But the world they moved through was changing too. As glaciation advanced, forests receded, grasslands expanded, deserts shifted north and south, and in the cold, life adapted. Animals grew thick coats, large bodies to retain heat, Woolly mammoths replaced elephants, steppe bison replaced forest grazers, saber-toothed cats and dire wolves hunted the Ice Age plains, and the people, our ancestors, watched them all. Those who lived in Africa faced new challenges. Periods of intense aridity would wipe out lakes, fragmenting populations. Isolation breeds divergence, and in those isolated valleys genetic differences accumulated. Small groups evolved independently, some disappeared, others survived. One such lineage, small in number but biologically distinct, would eventually give rise to Homo sapiens. But in this early world, survival was not simple. Every change in climate reshuffled the board. During warmer interglacials, trees returned and forests marched northward. Animals migrated. So did humans. Then the glaciers crept forward again, and everything reversed. The rhythm was slow but relentless. Ice advanced. Rain patterns shifted, sea levels dropped. Coastal plains emerged, opening new paths, only to vanish again as water returned, and with every cycle, life adapted, evolved, moved or died. In Europe, the cold birthed new humans. Homo neanderthalensis, the Neanderthals, emerged around 400,000 years ago. Stocky, strong, thick-browed, they were built for the Ice Age. Their bodies conserved heat. Their cultures, still mysterious, included burial, tools, fire, perhaps even art. They were not brutish. They were kin. Farther east, the Denisovans emerged, known mostly from fragments of bone and DNA. Their world stretched from the Siberian tundra to the Himalayan foothills. Little is known, but their legacy lingers in the genes of modern humans from Asia and Oceania. And back in Africa, Homo sapiens was beginning to look familiar. Not just in form, but in mind. By 300,000 years ago, anatomically modern humans had appeared. Not all at once, not with fanfare, but the shape of our skull, our brain, our hands and feet, they had arrived. What followed was perhaps more important. Behaviour. We began to make art. Not just function, but expression. Symbols carved into ochre. Shell beads worn as ornaments, geometric patterns. A language of imagination, not just survival. We fished, cooked, cared for the sick, shared food, buried our dead, and we began to look upward. The stars would come later, with stories. But the gaze, that long human gaze into mystery, had begun. The world these early humans lived in was both alien and intimate. Africa, where our story began, was a land of contrast. In some regions, lush woodlands teeming with life. In others, scorched savanna stretching toward endless horizon. In the glacial north, ice blanketed the land. In the south, deserts waited. The equator was not always warm. Monsoons shifted. Lakes appeared and disappeared. Sometimes twice in a human lifetime. In the east, volcanic highlands, rift valleys yawning wide. The earth cracked open, and from its depths rose obsidian, ash, and fertile soil. Our ancestors walked along those rift escarpments, leaving footprints that fossilized into stone. Moments, caught mid-stride, preserved by ashfall and time. They travelled along coastlines, through river corridors, across newly exposed land bridges. They hunted gazelle, fished estuaries, followed elephants, watched the seasons. And when the cold came down once more, they endured it. It's tempting to imagine the Ice Age as only cold, endless snow and frostbitten fingers. But the truth is subtler. It was a time of variation, extremes, not one climate but many, dry, wet, hot, cold, often in rapid succession, and in that variability, intelligence became an evolutionary asset. Big brains are costly, they demand calories, oxygen, care, but they pay off in flexibility, in memory, in social bonds, in planning. A clever brain doesn't just react, it anticipates, it stores knowledge, it invents. And as the world shifted beneath their feet, early humans needed that more than ever. A sudden drought might make fruit vanish. A clever toolmaker could dig roots instead. A freezing wind might kill game. A resourceful mind could trap smaller prey. A flooded river might block a route. A cooperative group might build a raft. Our intelligence was shaped in part by the need to survive change, and perhaps that's still true today. By 100,000 years ago, Homo sapiens had begun to leave Africa in earnest. A trickle, then a wave, along the Red Sea coast, through the Sinai, into the Levant, across Asia, into Australia, eventually across Beringia into the Americas. Every step, a new world, new animals, new challenges, and new encounters with Neanderthals, Denisovans, and perhaps others. We mated, fought, learned, adapted, genes mingled, tools were shared, firelight was passed hand to hand. By the time the last great glaciation reached its peak, around 20,000 years ago, our ancestors were scattered across 6 continents. They were painting mammoths on cave walls, building shelters from mammoth bones, sewing furs with bone needles, telling stories around fires. And above them the ice loomed, beautiful, terrible, endless. But in its shadow, humanity didn't just survive, it became itself. To understand how the Ice Age sculpted us, we must look not only at the glaciers that advanced, but at the forces that summoned them. It's a curious thing. The most powerful events in Earth's history often unfold so slowly that no single creature notices. A volcanic eruption might darken the sky for months, yes, but a shift in the tilt of Earth's axis, that takes thousands of years, and yet it can remake continents, kill forests, change the course of evolution. The Ice Age was no exception. It did not begin with a bang, nor with a crack of thunder or a frozen sunrise. It began with a whisper. The Earth's orbit wobbled, tilted, danced to the rhythm of the cosmos, Milankovitch cycles. The long, slow shifts in Earth's orientation toward the sun had been at work for eons. But now, conditions were just right. The north received less summer sunlight, winters grew colder, and snow that once melted began to linger. Year after year it piled higher, compressed into ice, hardened, and then, slowly, it began to move. Glaciers don't crash like tsunamis, they crawl, a few inches a day. But with weight and time and silence, they are among the most powerful forces Earth has ever known. They scraped valleys into U-shapes, dragged boulders across entire countries, ground mountains into flour-fine dust. They changed the very shape of the land. In North America, the Laurentide ice sheet blanketed most of Canada and much of the northern United States. Ice reached as far south as what is now New York City. Chicago, Minneapolis, Seattle, all under hundreds of meters of ice. In Europe, the Fennoscandian ice sheet swept across Scandinavia, over Germany, down into northern France and Poland. With so much water locked in ice, sea levels plummeted. Coastlines crept outward by hundreds of kilometers. Land bridges emerged, inviting migrations across the Bering Strait between Japan and Korea into Britain from mainland Europe. But the Ice Age wasn't just about glaciers, it was about the cascade. The planet is a delicately balanced system. Tug one thread and others unravel. As the ice sheets expanded, they reflected more sunlight, a phenomenon known as albedo. White surfaces bounce solar radiation back into space, cooling the planet even further. A feedback loop. More ice, more reflection, more cold. Temperatures dropped, winds shifted, rainfall patterns changed. Deserts expanded in the tropics, while permafrost swallowed the north. The Amazon rainforest shrank. Dust storms swept across Eurasia. In some places, lakes dried up. In others, they grew. The world was not frozen everywhere, but it was transformed. Atmospheric carbon dioxide, a greenhouse gas vital for trapping heat, also declined. Some of this was natural, a result of cooler oceans absorbing more CO2. Some of it was linked to biological processes, plankton blooms in the oceans, locking carbon in tiny shells that rained slowly to the seafloor. Volcanoes added their voice, as they always do. Eruptions can warm or cool, depending on what they release. A long sequence of volcanic activity in the tropics may have helped trigger global cooling millions of years earlier. By belching sulfur aerosols into the sky, blocking sunlight, or by exposing fresh rock that absorbed carbon as it weathered. The Earth is always multitasking, and yet, even in the coldest epochs, warmth never entirely vanished. There were pockets, refugia, places where life huddled in the lee of glaciers, river valleys, thermal springs, caves, microclimates where plants clung to life, where animals grazed, where humans could hunt and shelter. These places mattered. They were the arcs of the Ice Age, not in a sudden stormy flood, but in a slow freeze. Evolution unfolded differently in each one. Populations were cut off, gene pools diverged, ideas developed in parallel, and when the ice retreated they met again, strangers who had once been kin. It's easy to think of the Ice Age as one thing, one stretch of cold, but it was not. It was a rhythm. For the last 2.6 million years, Earth has cycled through dozens of glacial and interglacial phases, each one triggered by those same orbital nudges. The last big one peaked about 20,000 years ago. Before that, another and another, some lasting tens of thousands of years, others shorter, some dramatic, some subtle, some regional, some global, and during each of them humans were there. Not always our humans, but our cousins, our ancestors, our story braided with theirs. When the cold tightened its grip, populations shrank. Some vanished, others adapted. When the warmth returned, the survivors spread, carrying fire and language, tools and stories to lands their grandparents had never seen. And through it all, our minds changed. There's a theory in anthropology called the variability selection hypothesis. It suggests that what shaped the human brain wasn't any one environment, but the unpredictability of them all. That living through constant change, wet to dry, cold to hot, forest to desert and back again, selected not for strength or speed, but for flexibility, for memory, imagination, collaboration, innovation. Those who could adapt to change survived. Those who could plan, remember, problem solve, teach, imagine, thrived. And what greater tutor of change than the Ice Age? To survive the cold was to master contradiction. You had to move, but also remember. You had to be alert to danger, but patient enough to wait. You had to rely on your group, but think for yourself. These are human traits not born overnight, but over millennia, sculpted by wind and scarcity and the soft crunch of snow underfoot. Fire was central, not just for warmth, but for social life, for cooking food, for protection, for ritual. The hearth became a gathering place, a centre of gravity. Around it, stories may have been born, oral traditions that encoded practical knowledge. Yes, but also something deeper. Wonder, meaning, belonging. And from fire came new possibilities. Cooked food is easier to digest. It frees up energy. Some scientists believe that this energy surplus allowed our brains to grow, generation after generation. Meat, tubers, roasted nuts and seeds. These fueled a transformation not just of diet, but of destiny. But food was never guaranteed. Ice Age ecosystems were fragile. A sudden climate swing could kill the prey, freeze the berries, dry up the roots, and so humans diversified. They learned to track animals across snow and time, to build traps, to fish with hooks carved from bone. They stored food, smoked it, dried it, buried it. They built clothing from hides, stitched together with sinew and bone needles. Some wore ornaments, beads, pendants, symbols scratched into antler or ivory. Not survival tools, something else. Identity, perhaps. Belief. and eventually they painted. Deep in the caves of France and Spain, where Ice Age winds could never reach, ancient humans left art that still speaks. Horses with flowing manes, mammoths in motion, hands stenciled on stone reaching across 20,000 years. These were not scribbles, they were precise, intentional, ritualistic. The caves may have echoed with chants, with drums, with the flicker of fire casting the painted animals into trembling life. We will never know exactly what they meant, but the impulse to depict, to remember, to express was unmistakably human. Even more astonishing, the urge to create was not isolated. In Africa, rock shelters show engravings older still. In Indonesia, handprints and animal figures. In Australia, ochre mines that stretch back tens of thousands of years. Different continents, different climates. Same mind. It suggests that by the late Ice Age, symbolic thinking was widespread. Language likely was too. Not just grunts, but grammar, metaphor, song. These, more than tools, may have been our real revolution. And as our minds bloomed, so too did our reach. Glaciers opened new pathways, across dry land that today lies underwater, from Siberia into Alaska, from Southeast Asia into Australia, from Europe into the British Isles, from North Africa into the Mediterranean. Human footprints spread across the world. We encountered Neanderthals, Denisovans, and perhaps others we've yet to name. Sometimes we fought, sometimes we mated, sometimes we learned. The DNA of modern humans carries traces of those meetings. Neanderthal genes influence everything from immune response to skin tone. Denisovan genes help Tibetans live at high altitude. Our species is not a pure line, it is a mosaic. And then, slowly, the cold began to lift. Not all at once, but the glaciers began to melt. The seas began to rise, forests crept back, rivers swelled, and in the brief window that followed, those precious millennia of relative calm, we planted seeds. Literally and metaphorically, the Ice Age had prepared us. It had forged our tools, our bodies, our minds, and now we began to settle, to cultivate, to build villages, then cities, to domesticate animals, to write. Civilization was not the end of the Ice Age story, it was its flowering. But the ice had written itself into our bones, our metabolism, our sleep cycles, our social instincts. Even now, in our cities and under electric light, we carry the echo of glaciers, and in that echo we are reminded, quietly, continuously, that we are a species born not in comfort but in adaptation, not in warmth but in resilience. Imagine a domino standing tall and still. Now imagine another, and another. Now picture 1,000,000 of them, linked across valleys and continents. The first one falls so slowly it seems like nothing has happened, but wait long enough, and eventually the whole board starts to shift. That's what the Ice Age did. Not through explosions or extinction events in the style of asteroids or volcanoes, but through the long glacial breath of climate pressure. Every change triggered another. Every feedback loop found a new path to follow. As the great glaciers advanced, they didn't just chill the air, they restructured the global ecosystem from the roots up. Start with the forests. In tropical zones, rainfall patterns began to shift. Where lush, closed canopy rainforests had once dominated, savannas began to take their place. Dense greenery thinned into scattered trees and open grasses. This was no subtle trim, it was a wholesale transformation. The Amazon basin, which today holds the world's largest rainforest, shrank dramatically. In parts of Southeast Asia and Central Africa, forest cover retreated to narrow strips along rivers and steep mountain refuges. For the animals that lived in the trees, it was a slow unravelling. Fruit-bearing trees became rare. Insects, flowers and leaves grew unpredictable. Those species that could adapt, who could forage, wander, wait, hung on. Those that couldn't disappeared into the fossil record, and with the forests gone came the dust. During cold, dry, glacial periods, winds picked up speed. Without trees to hold soil in place, dust storms swept across whole continents. Loess, fine, powdery silt, blanketed regions of northern China, Central Asia and Europe. Entire landscapes were reshaped not by bulldozers of ice, but by invisible rivers of airborne sediment. In places, these dust-covered plains became fertile grasslands, tundra steppe ecosystems rich in herbs and low-growing shrubs. And in those grasses, new opportunities bloomed. Grazing megafauna, mammoths, giant sloths, woolly rhinoceroses, reindeer, thrived. Their huge, slow-moving bodies crisscrossed continents, chewing their way through an environment built for browsing. These were not rare creatures the way elephants are today. They were abundant, everywhere. Herds that thundered over the steppe, families that migrated with the seasons, their lives in sync with the cold, and the grass, and the wind. But this abundance came at a cost. Large-bodied animals reproduce slowly. They depend on wide ranges. They require stable food chains. And when the ice began to retreat again, when temperatures ticked upward, plants shifted, and human hunters spread farther north, the fragile balance of Ice Age life began to tilt. The mammoth, the ground sloth, the woolly rhinoceros, they'd endured glacial pulses for hundreds of thousands of years. But they had never faced what came next, a world that changed too fast, and with it, a species unlike any other. We'll return to us in a moment, but first, let's stay with the land. As glaciers melted, their retreat was both graceful and violent. The meltwater pooled at the edges, carving rivers from solid rock. In some places, it created massive lakes, held in place only by temporary walls of ice. When those icy dams broke, the results were cataclysmic. One of the most dramatic examples is the Missoula floods, which shaped the American Pacific Northwest. Ice Age glacial Lake Missoula, larger than modern Lake Ontario, was trapped behind a glacier dam in what is now Montana. When that dam failed, likely dozens of times over several millennia, water roared westward at highway speeds, scouring the Columbia River Gorge and carving giant ripple marks into bedrock still visible today. Elsewhere, similar floods reshaped the British Isles, created the English Channel, and transformed the Black Sea from a freshwater lake into a briny inland sea. River systems everywhere were rewritten, ancient coastlines submerged, the world remade again and again. And as the ice shrank, the Earth did something curious. It rebounded. Glacial ice is heavy, so heavy that it pushes the very crust of the Earth downward. As the glaciers melted, the land beneath them began to rise again, slowly. This process, called isostatic rebound, is still ongoing. In parts of Scandinavia and Canada, the land is rising by nearly a centimetre per year. Imagine a continent breathing, slowly exhaling from the weight of history. But while the land rebounded, many species did not. The Ice Age megafauna collapse is one of the most debated extinctions in Earth's recent history. By around 10,000 years ago, as the last great glaciation faded, over 70% of large-bodied mammal species in North America were gone. Similar patterns unfolded in South America, Eurasia, and Australia. Gone were the mammoths. Gone were giant ground sloths the size of SUVs. Gone were saber-toothed cats, short-faced bears, giant beavers, massive armadillo-like glyptodonts. What caused it? The simplest answer is many things, and they all happened at once. First, climate change. Rapid warming at the end of the last glacial period disrupted habitats faster than species could move. Forests returned to areas that had been open steppe. Water sources shifted. Plants disappeared. Food chains unravelled. Second, humans. As our ancestors expanded across the globe, they brought something the Ice Age had never seen: coordinated, intelligent, tool-using predation. We didn't just hunt. We planned hunts. shared strategies, made weapons that could kill from a distance. We set fires to drive game. We stored food, shaped environments, and hunted with an efficiency previously unseen on the planet. This is known as the overkill hypothesis, and while it's debated, there's evidence to support it. In North America, large mammal extinctions followed closely after the arrival of humans. In Australia, a similar pattern, massive marsupials vanishing within a few thousand years of human settlement. But it wasn't just killing, it was timing. Species already weakened by climate shifts, stressed, fragmented, declining, now faced a predator that could think in futures. That combination may have been too much, and the ripple effects continued. With megafauna gone, ecosystems shifted. Grasses grew taller without being grazed. Forests advanced in places once held open by mammoth herds. Fires behaved differently. Predators lost prey. Scavengers lost leftovers. It was a quiet planetary rearrangement. Not a crash, but a slow redrawing. As the animals changed, so did we. The people who lived through this unravelling didn't have charts or satellite data. They didn't know the planet was warming, or that ice sheets were collapsing. But they felt it in the timing of the herds, in the disappearance of familiar plants, in floods that erased hunting grounds, or in forests that replaced open plains. They were flexible, resilient, but they had to reinvent survival, again and again. In some places they followed the retreating animals north. In others they began to fish more, gather more, diversify their diets. They invented new tools, harpoons, fishhooks, nets, traps. They shaped bone into needles, sinew into thread. They began to settle, first seasonally, then semi-permanently. Seeds were planted, clay was fired, dogs were domesticated. A new kind of human life was being born, not just of mobility and fire, but of rhythm, of staying, of shaping the land, not just moving through it. And in time, this would become agriculture. But the foundations were laid in the cold. The instincts to observe, adapt, collaborate. The memory of lean times, the maps drawn in minds, not paper. The knowledge passed down in stories, in rituals, in firelight gestures and flint-knapped stone. In places like the Fertile Crescent, once a cooler, wetter refuge during glacial droughts, these skills found fertile ground. Here, after the glaciers retreated, humans began to cultivate wheat and barley, to store grain, to domesticate sheep and goats. The Neolithic Revolution, the transition from hunting to farming, was not a sudden switch. It was the culmination of Ice Age pressures, a quiet, patient preparation. In the Americas, similar patterns emerged independently. In Mesoamerica, maize slowly took form from a wild grass called teosinte. In the Andes, potatoes. In East Asia, rice. In Africa, sorghum and millet. Each of these revolutions bore the mark of their environment, and of the people who had survived millennia of shifting cold and warmth. The Ice Age had scattered humanity across the globe. Now it had prepared them to settle it. But even as we began to shape the land continued to shape us. Glacial retreat carved out new lakes, like the Great Lakes of North America, still filling the ancient scars left by ice. River valleys formed, fertile floodplains appeared, and in these places civilizations would one day rise, but the climate never stayed still. Even within the Holocene, the warm interglacial we're in now, there have been disruptions, cold snaps, flood pulses, shifts in monsoons. The memory of the Ice Age lingers not just in stone, but in our nervous systems, in our myths, in our caution. And now, for the first time in Earth's history, the direction of the climate is not being pushed by orbital wobbles or volcanic belches, but by us. We burn the remnants of ancient forests. We release gases once locked in stone. The warming comes fast, faster than at the end of the last glacial maximum. And again, species struggle to keep up. Again migration patterns unravel, again ice retreats, but this time it's not a passive unfolding. We're not just watching, we are the cause, and that brings us full circle, because the very adaptability that allowed us to survive the Ice Age, that ability to think forward, to remember back, to cooperate and learn, now gives us the tools to respond, to repair, to rethink, but only if we listen to the ice, to the fossils, to the stories etched in loess and bones and bubbles of ancient air. The chain reactions that made us human are not finished. They never are. We are still in the middle of a process, still being shaped, still shaping. The Ice Age was not just a chapter, it was a teacher. And the lessons, if we're paying attention, are still being offered. If the Ice Age shaped us, it did so not as an isolated sculptor, but as one in a long lineage of transformations, each with its own rhythms and textures, each stitched into the fabric of deep time. Earth, after all, is a planet of cycles. It inhales and exhales continents. It buries oceans and raises mountains. It erases the old and writes the new. And sometimes it does so quietly, over millions of years, sometimes in the blink of a cosmic eye. The Ice Age we know, this quaternary glaciation, wasn't the first, nor the coldest, nor the longest. It's simply the one we happen to be born into, the one that left its fingerprints in our blood. To see the bigger picture, we must first step back, far back, past the rise of mammals, past the great reptiles, past the first forests, past even the first skeletons in the sea. Keep going. Roughly 720 million years ago, something extraordinary happened. The Earth froze, completely. It's known as Snowball Earth, and it wasn't poetic hyperbole. Glaciers stretched from pole to equator. The oceans may have frozen over entirely, trapped beneath a shell of ice dozens, perhaps hundreds, of meters thick. The sky dimmed. Photosynthesis nearly stopped. Life, such as it was, retreated to hydrothermal vents, cracks in the ice, and tiny pockets where liquid water clung like a secret. We don't know exactly what triggered it. A decrease in volcanic activity, a dip in atmospheric CO2, a continental arrangement that funneled weather systems just so, perhaps a combination. But what we do know is that it nearly wiped the board clean, and then changed everything. When the ice finally melted, after millions of years of slow volcanic outgassing warmed the atmosphere, Earth bloomed. Oxygen levels rose, complex life began to stir. The Cambrian explosion, that sudden burst of biological innovation some 540 million years ago, may have been fueled by nutrients released in the wake of that ancient thaw. That was one pattern: ice, collapse, reset, flourish. It would not be the last. The story of Earth's history is punctuated by mass extinctions, at least 5 major ones according to the fossil record. Some were caused by volcanic eruptions that choked the sky, others by meteorites like the famous Chicxulub impact that ended the reign of the dinosaurs 66 million years ago. But not all extinctions came with fire, some came with cold. Roughly 360 million years ago, during the late Devonian, life in the oceans began to fade. Coral reefs collapsed. Fish diversity plummeted. A series of environmental shifts, possibly linked to glaciations in Gondwana, the ancient supercontinent that spanned the southern hemisphere, triggered a drawn-out crisis. Oxygen levels in the seas dropped. Algae bloomed and died. The oceans grew hostile and life retreated. And then again, around 34 million years ago, the Eocene-Oligocene transition. Antarctica, until then a forested temperate land, began to freeze. CO2 levels fell, glaciers formed, the world cooled rapidly. Mammals adapted, migrated, evolved. Grasslands spread. Horses shrank. Apes and monkeys began their long divergence. Patterns began to emerge. Climate change wasn't just background, it was often the main character. Whether the trigger was volcanic, orbital, biological or celestial, the result was the same. The world shifted, and life had to respond, and not just in bodies, but in minds. Take the Permian-Triassic extinction. Around 252 million years ago, the worst the Earth has ever endured. Over 90% of marine species vanished. On land, the toll was almost as high. It was the closest life has ever come to total erasure. The cause? Likely massive volcanic eruptions in what is now Siberia. The Siberian Traps, a vast region of ancient lava flows, belched CO2 and methane into the atmosphere for thousands of years. Temperatures soared, oceans turned acidic, anoxic, dead zones spread. And the recovery? It took over 10 million years. But from that devastation came something new. The rise of the dinosaurs, and from their extinction, the rise of mammals, and from mammals, us. It's humbling in a way to realise how many chapters came before, how many stories ended so ours could begin, and how each extinction, each climate pulse, each geological shiver paved the way for something unimaginable. The Ice Age, then, isn't just a curious blip in the weather, it's part of a long tradition, a member of a powerful, patient family of planetary events that push life to the edge and sometimes beyond. And yet, within these cold intervals, something else happens too. Innovation. The cold doesn't just kill, it clarifies. It forces species to do more with less, to collaborate, to migrate, to remember. And over time, those pressures don't just create survivors, they create thinkers. And thinkers, as it turns out, are excellent at enduring uncertainty. Zooming back in, let's return to the Quaternary, the glacial age we call our own. What makes it strange is not just that it happened, but when it happened. For most of the past 500 million years, Earth has been relatively warm. Ice caps were rare. CO2 was higher. Polar regions were sometimes forested. Dinosaurs once roamed temperate swamps near the poles. Even Antarctica, now buried beneath kilometres of ice, was once green, wet, alive. So why did the planet flip, seemingly suddenly, into cycles of glacial cold? It's likely a combination of three things. First, the rearrangement of continents. As tectonic plates drifted, the Antarctic continent became more isolated. Ocean currents like the Antarctic circumpolar current formed, creating a thermal barrier that trapped cold around the South Pole. Second, the rise of mountain ranges, especially the Himalayas, which are still growing. As fresh rock weathers, it pulls CO2 from the air and locks it into sediments. It's a slow carbon vacuum, dragging down greenhouse gas concentrations over millions of years. Third, those now familiar Milankovitch cycles, the planet's slow orbital rhythms aligned with new geography and low CO2 to produce the perfect recipe for recurring ice. It wasn't immediate, but once it began, the cycle locked in, and in that cycle, a peculiar species of primate found its crucible. It's worth remembering that for most of the Ice Age, humans were not alone. We've said it before, but it bears repeating. The Neanderthals were not a side note. They were a sibling. They buried their dead, cared for the injured, wore jewellery, possibly sang. And then, they were gone. Why? Again, no single answer. Some genetic evidence suggests Neanderthals had smaller population sizes, making them more vulnerable to environmental stress. Others point to resource competition, or disease exchange, or simple bad luck. What we do know is that their disappearance wasn't total. Their DNA lingers in many of us, a faint whisper of another lineage still moving through time, and they were not the only ones. Across the ancient world, other hominins existed. Denisovans in Asia, the enigmatic Homo floresiensis in Indonesia, nicknamed the Hobbit for its small stature. Possibly others we've yet to uncover. Human history, it seems, is not a straight line, but a braided river, with channels that merge and vanish and emerge again, all of it shaped by climate, because as the Ice Age advanced and retreated, it opened windows of movement and then slammed them shut. During glacial lows, sea levels dropped and land bridges appeared. humans crossed into Australia, perhaps by boat, into the Americas, likely by land, or maybe even by a coastal route now underwater. And then, when the glaciers melted, those doors closed. Rising seas drowned the bridges. Populations became isolated. Languages diverged. Cultures branched and flourished in parallel. And yet, through it all, the signature of the Ice Age remained. Even now we feel it. In our genomes, where adaptations to cold still echo in how we regulate body heat, metabolize fat, or respond to altitude. In our landscapes, where lakes, valleys and hills still carry the fingerprints of ice long gone. In our myths, where stories of floods, long winters, or journeys across barren lands still whisper from ancient memory. And perhaps most of all, in our ability to imagine a world that once was different, and maybe again. Because if the Ice Age taught us anything, it's that the Earth does not stand still. It moves, it shifts, and it invites those who dwell upon it to move with it. Sometimes gently, sometimes with urgency, but always with change. And that change, for all its danger and grief, is also the heartbeat of life. It clears the canvas, forces reinvention, and occasionally when conditions align it creates a being who can ask why. Why here? Why now? Why us? And so we return, once more, to the cold. Not as victims, not even as students, but as its unlikely heirs. If the Ice Age shaped the world and sculpted us within it, then the second great shaping came long after, the moment we began to realise it had happened at all. Because for most of human history no one knew. The first farmers, the first cities, the first kings and scribes and prophets, all lived in the long warm shadow of the last glacial retreat. The ice had gone, the waters had risen, the megafauna were mostly vanished, and in their place came ploughs, bricks, bronze. And so the great frozen world that made us slowly slip from memory. It lingered in myths, perhaps, flood stories, buried giants, tales of long winters and wandering beasts. But not until relatively recently, within just the last few centuries, did we begin to truly ask, why are there boulders where they shouldn't be? Why do valleys curve the way they do? Why do the bones of giant, unfamiliar animals lie buried beneath our feet? These weren't always scientific questions at first. They were puzzles, curiosities, clues in landscapes that had stopped making sense. And slowly they drew curious minds into a mystery that spanned continents. One of the earliest of those minds was Ignaz Venetz, a Swiss engineer in the early 1800s. While working on alpine infrastructure, Venetz noticed that many of the valleys and hillsides in Switzerland bore scars, not from rivers, not from landslides, but from something heavier, something that had moved with purpose. He saw boulders perched like forgotten luggage miles from any mountain, parallel scratches carved into hard stone, piles of unsorted debris that no stream could have delivered. He began to suspect that glaciers, those frozen rivers winding through alpine peaks, had once been much larger, that they had once stretched beyond the mountains themselves, down into valleys and plains. He was mostly ignored, until another Swiss mind took it further. Louis Agassiz, a naturalist and geologist, was bold where Venetz had been cautious. In 1837, Agassiz proposed that much of Europe had once been covered by a vast sheet of ice, not just the Alps, but the lowlands too, not just mountain glaciers, but continental ones. He wasn't merely suggesting a cold spell. He was rewriting the story of Earth. The evidence was mounting. Erratic boulders, huge rocks carried and dropped in places where no local force could explain them. Moraines, ridges of rock and gravel left behind by retreating ice. Glacial striations, deep parallel grooves carved into bedrock by moving ice embedded with stones. U-shaped valleys that did not fit the profile of river erosion. At first his colleagues laughed. Agassiz was mocked for suggesting that Europe had once been buried under kilometres of ice. But slowly his ideas took hold. It helped that the landscapes themselves whispered his defence. Farmers had seen those boulders their whole lives. Shepherds had walked those valleys. Engineers had dug through those gravel hills. The land remembered. And now, at last, someone was asking it the right questions. Soon, the idea of an ice age spread. In the decades that followed, geologists across Europe and North America began looking at their home terrain with fresh eyes. In Germany, in Britain, in the American Midwest, glacial deposits, once seen as chaotic and random, began to resolve into patterns. Maps were drawn, timelines debated, new terms coined: Pleistocene, glacial maximum, moraine, low S. But the most astonishing realization came later. It wasn't just one ice age, it was many. What we call the Ice Age was actually a long period, stretching back more than 2.5 million years, with dozens of glacial advances and retreats. Each one reshaped the world, each one shifted the climate, each one challenged life to adapt or disappear. But how could scientists know this? How could anyone reach that far back in time? The answer lay buried, in mud, in ice, in coral, in teeth, in the slow, meticulous work of people willing to listen to the ancient record. Take deep sea cores. Beginning in the mid-20th century, oceanographers and geologists began drilling into the seafloor, pulling up long cylinders of sediment. Each layer captured a chapter: dust blown in from deserts, shells of plankton, chemical fingerprints of ancient temperatures. By studying the isotopes of oxygen in those tiny fossil shells, scientists could infer how much ice was on Earth at different times. More ice meant lighter isotopes locked in glaciers, leaving heavier ones in the oceans. These patterns, icy barcodes from the past, revealed the rhythms of glacial cycles in astonishing detail. The work of Cesare Emiliani in the 1950s and 60s was especially groundbreaking. He helped demonstrate that these glacial cycles matched, almost perfectly, the predictions made decades earlier by Milutin Milankovitch. Which brings us to Milankovitch himself. A Serbian civil engineer and mathematician, Milankovitch wasn't a field geologist. He didn't dig fossils or read core samples, he read the heavens. In the early 20th century, Milankovitch began calculating the exact variations in Earth's orbit, tilt and wobble, how each changed over tens of thousands of years. He theorized that these astronomical cycles, by changing the amount and distribution of solar energy reaching the Earth, could trigger glacial and interglacial periods. At first, his ideas were too abstract, too mathematical. They sat mostly unread. But as isotope records accumulated and glacial deposits were dated, a match emerged. His cycles were real, and they had shaped the planet's breath. Later, in the 1970s, the Climate Project, a massive international effort, reconstructed the climate of the last glacial maximum using data from ocean cores, land-based sediments, and ice. It was among the first global pictures of an ancient climate, and it confirmed just how different the world had been. Where today you find farmland, there had been tundra. Where now there is ocean, there had been dry land. Where cities now rise, glaciers had once carved stone. Still, perhaps the most poetic records came from the cold itself, from ice. In the heart of Antarctica, on a frozen plain called Dome Sea, and again on the Greenland ice sheet, teams of researchers spent years, decades even, drilling into the ice. Each layer they reached had once been a snowfall, pressed, compacted, turned to solid ice, but still holding the tiniest bubbles of ancient air. The Vostok ice core extracted from East Antarctica reached back more than 400,000 years. Later, the Epica Dome Sea core would stretch that to over 800,000. Those trapped bubbles are like whispers. You can measure their CO2 content, their methane, their isotopic ratios. From them, you can reconstruct past temperatures, past atmospheres, past seasons. You can see the Earth breathe. These records didn't just confirm glacial cycles, they illuminated the feedback loops, the way cold reinforced itself, the way CO2 and temperature moved hand in hand. and crucially, they let us compare. The last time Earth's CO2 levels were as high as they are today was hundreds of thousands of years ago, in a much warmer world. And yet here we are, racing toward that warmth again, but this time not by orbit or tilt, this time by fire. The contrast is sobering, but the method, how we know, is astonishing, because it's not just core samples and equations, it's people, names, hands in cold mud, eyes behind microscopes, patience measured in lifetimes. People like Mary Leakey, who uncovered the footprints of early humans in East African ash, silent steps preserved by volcanic eruption and time, or Svante Pääbo, who pioneered techniques for extracting ancient DNA from Neanderthals, Denisovans, and more. His work showed, beyond theory, that our ancestors interbred, that we are genetically a chorus, or Jacques-Louis Boucher de Perthes, who in the 19th century insisted that the stone tools he found alongside fossilised animal bones in northern France proved that humans were older than the Bible said. He was mocked, until others confirmed his finds. Or Florentino Ameghino, the self-taught Argentine paleontologist who uncovered extinct South American megafauna and insisted, sometimes controversially, on the antiquity of human life in the Americas. Or Marslan Bull, who first reconstructed a Neanderthal skeleton, and who in doing so accidentally cemented the idea of the brutish caveman for a century. Science too has its myths and its corrections. These were not just scientists, they were storytellers, listeners, people willing to ask what happened here. Why does this rock look like that? Why is this tooth next to this charcoal? And their curiosity opened a portal, a way to look back, not with longing or fear, but with awe, because the Ice Age isn't just something that happened to mammoths and glaciers, it happened to us. We were there, and the only reason we know that is because someone knelt down, brushed away the dust and took the time to wonder. Perhaps the most beautiful part is that this story is still unfolding. New caves are still being found, new genetic data is being sequenced, climate models are improving, and beneath melting glaciers new fossils sometimes emerge, quietly, shyly, asking to be understood before they vanish. The Earth is still talking, and for now, we are still listening. If stories are what make us human, then science is how we listen to the stories the Earth tells when no one else is around. Because the Ice Age didn't write a diary, it didn't leave behind a scroll or a voice recording. What it left was evidence, chemical traces, isotopic signatures, layered sediments, fractured teeth, shards of obsidian and flecks of pollen caught between grains of sand. It whispered in the language of dust, bones and frozen breath. And slowly, gently, we've been learning to read it. Let's begin where the cold lives longest, in the ice. The ice sheets of Greenland and Antarctica are more than just frozen water. They are time machines. Every year a layer of snow falls. That snow traps tiny particles from the atmosphere. Bits of ash, spores, sea salt, and most importantly, air. That air gets locked into bubbles, preserved as the snow compacts into firn, then solid ice. Each layer is a page, each bubble a syllable. By drilling deep into these ice sheets, sometimes kilometers down, scientists extract cores that stretch back hundreds of thousands of years. The Epica Dome Sea core in Antarctica reaches over 800,000 years into the past. That's 8 full glacial cycles, each recorded in breathtaking detail. And what can we learn from those icy spirals? Quite a bit. First, we learn about the composition of the atmosphere. Scientists measure the amount of carbon dioxide, methane, and nitrous oxide in each bubble. These are greenhouse gases, the ones that trap heat in the atmosphere. What we find is a tight correlation. When CO2 is low, the planet is cold. When CO2 is high, warmth follows. It's not always clear which comes first, temperature or CO2, but the relationship is consistent. They dance together, reinforcing each other. A feedback loop. Second, we learn about volcanic eruptions. Ash layers embedded in the ice, sometimes just a few microns thick, reveal explosive events. The ice can even preserve traces of sulfur dioxide, which helps reconstruct the size and impact of ancient eruptions. Some layers show years of cooling that follow, some hint at drought. Some, surprisingly, suggest that humans were already there, adapting in the ash-filled aftermath. Third, we measure dust. During colder, drier periods, deserts expand. Winds strengthen, dust travels farther, so more dust in the ice. A dustier, colder world. Less dust. Wetter, warmer intervals. The pattern is so clear you can see it with the naked eye. Pale ice in warm years, darker bands in the glacial ones. But the ice isn't the only archive. Let's walk now to the ocean floor. Just as snow falls in layers at the poles, sediment falls in layers at the bottom of the sea. Plankton die. Their shells drift down. Dust from deserts, pollen from forests, ash from volcanoes. Over millions of years, the ocean floor becomes a library, page after page pressed into mud and stone. Inside these cores, scientists find the shells of microscopic creatures called foraminifera. These tiny plankton build their shells from calcium carbonate. And here's the magic. The ratio of oxygen isotopes in their shells depends on the temperature of the water they lived in, and on the volume of global ice. It works like this. There are two main isotopes of oxygen, O16 and O18. Water molecules with O16 are lighter and evaporate more easily. During glaciations, more O16 gets locked in ice sheets. This leaves the oceans enriched in O18. So the foraminifera living in those oceans build shells that reflect this ratio. When scientists measure that ratio in fossil shells, they can reconstruct not just sea temperatures, but ice volume, a double climate record in every grain. This is called oxygen isotope stratigraphy, and it's one of the most powerful tools we have for understanding the timing of glacial cycles. It's also how we confirmed Milankovitch's theory. The isotope records match the predicted cycles of orbital variation almost perfectly, but the science doesn't stop there. Back on land, clues lie buried in loess, those fine windblown deposits found across Eurasia and North America. Loess builds up during cold, dry glacial periods when vegetation can't hold the soil in place. When the climate warms, soils form instead. These alternating layers of dust and soil create a paleoclimatic barcode. Glacial, interglacial, glacial, interglacial, stretching back millions of years. Each layer holds magnetic particles, chemical signatures, even preserved pollen. And from that pollen, we can reconstruct ancient vegetation, what plants were growing, and therefore what the climate was like. In some places, ancient lakes hold similar stories. Lake sediments in East Africa, for example, reveal the fluctuating pulse of rainfall over hundreds of thousands of years. Wet periods show thick, dark layers, rich in organic material. Dry periods leave pale, silty bands. Diatoms, tiny algae with glass-like shells, preserve the chemistry of the water itself. All of it builds a story. When the monsoons failed, when lakes dried to dust, when humans may have been forced to migrate, adapt, or disappear. Even stalagmites in caves hold climate secrets. As rainwater seeps into limestone caves, it picks up minerals. When it drips from the ceiling, it leaves behind tiny deposits of calcite, forming stalactites and stalagmites. These grow slowly, just fractions of a millimetre per year, but they're stable, layered, and datable. And here again, oxygen isotopes reveal temperature and rainfall. Sudden shifts in the chemistry of a stalagmite, visible under a microscope, might record a centuries-long drought, or a return of heavy monsoon rains, or even a volcanic winter. We read these cave calendars like tree rings made of stone. Each data point, each measurement, is a whisper. One voice, in a much larger choir, but bring them together. Ice, mud, ash, coral, teeth, and a picture begins to form. And in that picture, something strange emerges. The Ice Age was never simple, because even as the glaciers waxed and waned, not all of Earth cooled evenly. Some regions warmed while others froze. Some shifted from forest to desert, others from ocean to grassland. The climate system was, and remains, profoundly complex. Which brings us to the models. Computer models are how we ask the past to speak back. They take all we know, all the physics of sunlight and clouds, of ocean currents and atmospheric chemistry, and simulate how the planet might have looked thousands or millions of years ago. Early models were clunky, limited. They could simulate temperatures but struggled with precipitation. They missed the complexity of monsoons or the subtlety of ice sheet dynamics. But today, with supercomputers, data from satellites and field stations, and the careful calibration of paleoclimate records, we can reconstruct glacial climates with astonishing clarity. We can see how shifting jet streams changed rainfall in the Sahara, how albedo feedbacks reinforced cooling in Canada, how ice sheet elevation created its own weather, even altering wind patterns thousands of kilometres away. And in the most advanced models, we can even simulate the spread of humans, where they could have walked, how they might have crossed rivers, what barriers the climate might have raised. These models are tested against the data, against pollen records, isotope curves, archaeological sites, and when they match, something quiet and beautiful happens. We glimpse not just what was, but how it felt. We see the storm that might have driven a group of humans to shelter in a cave in Spain, the drought that emptied a lake in East Africa, the moment the snow melted from a mountain pass and a new valley opened to explore. We aren't just measuring climate, we are measuring possibility. One particularly vivid example lies in the story of Lake Megafauna. Today, Libya's Fezzan region is one of the driest places on Earth. But deep beneath the sand lie ancient lake beds, evidence of vast freshwater seas that once stretched hundreds of kilometres. Sediments from these fossil lakes tell of periods during interglacials when the Sahara bloomed. There were fish, crocodiles, trees, and humans. Archaeological evidence, stone tools, hearths, middens, suggest that people lived along these lake shores 130,000 years ago, and again 80,000 years ago. Their presence was not marginal, it was sustained. But then the orbit shifted, the monsoon retreated, and the lakes disappeared. What once was Eden became exile. Stories like these exist across Africa, the Middle East, Central Asia, dry lands that remember wetness, caves that remember song, ancient lakes that remember swimmers. And what's astonishing is how consistent the signal is. Whether in DNA, in dust, or in data, the climate pulses repeat. Cold to warm, wet to dry, pressure to release. It is that pressure, slow, quiet, cumulative, that shaped evolution, not in single steps, but in nudges. A lake dries up, a people move, a drought lingers, a mutation survives. Repeat that a few thousand times, and you get us. Even today we carry the legacy in our biology. Our circadian rhythms, the 24-hour cycle of hormones and alertness, are tuned to light and darkness, echoes of a time when the length of the day dictated survival. Our metabolic responses, how we store fat, how we burn it, may be shaped by Ice Age famines, by ancestors who had to endure long winters with little food. Even the shape of our noses, the colour of our skin, the curl of our hair, they're all adaptations to the climate zones we spread into, to sunlight, to humidity, to frost. And that's not even counting the cultural memory, stories of floods and long journeys, of lost homelands and promised lands, of golden ages and dark winters, of the sun standing still. Myths like these show up in culture after culture, scattered but familiar, perhaps seeded by real events experienced at the edges of an unstable world. Science doesn't prove myths, but it gives them a frame, and sometimes that frame glows. Because in the numbers and graphs, the isotope curves and sediment cores, We are not just finding patterns, we are finding ourselves. It's easy to forget, looking at a graph of global temperature anomalies or methane fluxes, that behind those lines are lives, people, children born during a warm pulse, elders who survived a cold decade, tribes that split, cultures that converged, firelight flickering against cave walls as the wind howled outside. The science gives us the skeleton, and it is our wonder that gives it flesh. So when we speak of oxygen isotopes and glacial geomorphology, of lowest deposits and orbital eccentricity, we are not speaking of dry, lifeless things. We are speaking of a world breathing, changing, remembering. We are speaking of the long, slow story of us, told in stone, whispered in ice, measured in dust, and carried forward, one quiet question at a time. The end of the Ice Age was not a sudden sunrise. It didn't arrive with trumpets or fanfare. There was no single day when the world thawed, no moment when the glaciers sighed and retreated never to return. Instead, it was like watching a breath exhale in reverse. Slow, hesitant. A world unfreezing not just in temperature but in rhythm, in possibility. Roughly 20,000 years ago, the last glacial maximum reached its peak. Ice sheets draped across North America, Northern Europe and Asia like vast white veils. Sea levels were over 100 meters lower than they are today. Mammoths still wandered the steppe. Human groups sheltered in caves or followed herds across tundra. But the sun slowly began to shift. Orbital changes, those patient celestial rhythms, tilted the planet just enough to begin warming the northern summers. The snow stopped lasting. Glaciers, once proud and immovable, began to lose their grip. And when they melted, the world shuddered. At first, the change was steady. Ice sheets thinned. Meltwater fed rivers. Sea levels began their slow climb. But then, as often happens in systems under pressure, the change quickened. Feedback loops kicked in. Less ice meant more dark surfaces, land, ocean, absorbing more sunlight. Temperatures rose further. Glacial lakes burst their bounds. Floods swept across continents. The planet leaned forward into something new. But change, especially after millennia of stillness, is not easy, and recovery is rarely peaceful. As the glaciers retreated, ecosystems scrambled. Tundra gave way to grassland, then shrubland, then forest. In North America, spruce forests marched north, chased by birch, then oak, then pine. Animals followed where they could. Some, like reindeer and muskox, kept pace with the cold, migrating into higher latitudes. Others, like the woolly mammoth or the saber-toothed cat, found themselves stranded in a world that no longer fit their design. The megafauna collapse, already underway, accelerated. The world's giants, the ones that had roamed for hundreds of thousands of years, now disappeared almost entirely. Ground sloths in South America, cave bears in Europe, giant kangaroos in Australia, all gone within a few thousand years. They left behind bones, footprints, silence. This extinction wasn't just a tragedy for individual species, it was a structural collapse. Megafauna are ecosystem engineers. They trample, graze, seed, and fertilize. Their absence reshaped landscapes. Forests grew denser. Grasslands changed in composition. Even fire regimes shifted. Fewer grazers meant more plant fuel, which meant more frequent and intense wildfires in some regions. The dominoes fell quietly, but not everywhere. Some regions became havens for resilience. In East Africa, pockets of biodiversity persisted through climatic swings. In Beringia, the land bridge that once connected Siberia and Alaska, species mingled, evolved, adapted. In highland refuge and river valleys, new combinations of life emerged, and among those survivors, humans. We didn't just survive the thaw, we adapted to it, exploited it, shaped it. As the ice pulled back, we followed the meltwater rivers, the blooming valleys, the rising forests. Fish returned to streams, birds migrated through new corridors, plants spread, and with them, knowledge. Which roots to dig, which seeds to gather, which animals to watch. Our tools changed, subtly at first. New flint knapping styles, harpoons, nets, then more dramatically, microliths, bows, pottery. In the Near East, people began to grind grains. In China, wild rice was gathered with increasing precision. In Mesoamerica, squash and maize entered early cultivation. These weren't overnight revolutions, they were slow accumulations, experiment, repetition, memory. And eventually, something shifted. We began to stay, not always, not everywhere. But more and more, people stopped chasing herds and started shaping land. Fields were cleared, seeds saved, villages formed. The wild became familiar, then domesticated. This was the Neolithic transformation, and it unfolded in the long wake of glacial retreat. Climate stability, relative, not perfect, offered a rare opportunity. Predictable seasons, reliable water, ecological niches that humans could learn and eventually command. But this stability came with strings, because to settle was to depend on rain, on soil, on animals that could be tamed, on plants that could be coaxed. And when those systems faltered, when drought came, or flood or frost, the consequences rippled. Early civilizations felt this deeply. The Sumerians, whose irrigation canals spidered across Mesopotamia, faced salinization as water tables rose and fell. The early farmers of the Indus Valley witnessed shifts in monsoon patterns that may have contributed to their collapse. In the Americas, the earliest mound-building cultures contended with changing river paths and flood cycles. Even the so-called Green Sahara disappeared. Once lush and full of lakes, it faded as the African humid period ended around 5,000 years ago. Forests gave way to sand, lakes dried, people moved or vanished, and so we learned, over and over again, the Ice Age was gone, but its legacy wasn't. It had carved the land, written its memory into mountains and riverbeds, etched its story into DNA. But more than that, it had trained us for uncertainty. Because the world did not become simple after the glaciers melted. It became more dynamic. Coastlines migrated inland. The English Channel formed, cutting Britain off from Europe. The Bering Land Bridge sank, isolating the Americas. River systems shifted, rainfall patterns danced, and in each case human cultures adapted. Fished new coasts, crossed mountains, invented boats, maps, trade routes. Culture flowed like water, finding the easiest path through complexity. And in the long term, over thousands of years, the Earth itself adjusted. Isostatic rebound continued and still does. Scandinavia, parts of Canada, even Scotland, still rising millimetre by millimetre as the crust rebounds from the weight of long-melted ice. Ancient shorelines can now be found perched hundreds of metres above modern sea level, silent witnesses to the Earth's slow balancing act. Elsewhere, glacial till and less soils deposited during the cold times became some of the world's most fertile farmland. Ukraine's black earth, the Midwest's deep topsoil, China's loose plateau. In these places, the ghosts of the glaciers feed millions. Even our waters carry the Ice Age's mark. The Great Lakes, for example, are not just big, they're enormous, carved by the slow drag of the Laurentide ice sheet and filled by its melt. They remain one of the largest freshwater systems on the planet, a glacial gift that still shapes economies, ecosystems and weather across the continent. And then there's permafrost. Vast swathes of the Arctic still hold ground frozen since the Ice Age, deep layers of ancient carbon, preserved for tens of thousands of years. In some places, mammoth tusks still emerge from riverbanks, ancient viruses, pollen, even footprints preserved in frozen mud. But the thaw continues, and with it comes release, not just of water, but of carbon, methane, DNA, secrets. We are living in the final flickers of a cycle that began long before writing, before farming, before cities. The Holocene, the warm period since the last ice age, has been stable but delicate. And now, as human activity warms the atmosphere faster than any post-glacial shift, we are entering unknown territory. It's a strange echo. Once, ice taught us how to survive. Now, its memory may help us understand what we're losing, because the ice age was not just destruction, it was pattern, feedback, balance. It was a living, breathing system of checks and flows. Water locked in ice meant lower seas, which meant exposed land, which meant migration. Melting ice meant floods, which meant new lakes, which meant life. It was chaos, but also choreography. And in that dance, we became who we are: adaptable, creative, resilient, restless. Even now, we crave movement. We build cities near coasts, even as the water rises. We farm on floodplains. We push into the wild edges. We follow the same instincts that once led us across frozen valleys in search of reindeer. And maybe that's not a flaw. Maybe it's a memory. A long, quiet remembering of what it meant to live in a world that shifted beneath our feet. Of what it meant to survive, then thrive, in the space between catastrophe and calm. Because recovery isn't a return, it's a becoming. And the Earth, like us, is still becoming, still melting, still shifting, still learning how to carry its past forward, just as we are. Somewhere in northern Europe, in the middle of a misted forest, there's a rock. It's smooth, enormous, out of place, dropped like a forgotten suitcase. The nearest mountains are hundreds of kilometers away. Beneath it, grass grows undisturbed. It does not move. Children climb it. Birds perch. Time drips past unnoticed, but the rock remembers. It was carried here, perhaps 18,000 years ago, gripped in the frozen belly of a glacier, dragged mile after mile, then gently released as the ice softened. It's an erratic, a boulder far from its origin, left behind as a calling card of the Ice Age. There are thousands like it, scattered across continents, quietly insisting that something enormous once happened here, that the world we know, the warmth, the green, the coastlines, the cities, is the exception, not the rule. The Ice Age wasn't an interruption in the Earth's history. It was the background condition for most of our existence. We didn't just survive it, we were forged by it. And now, we've left it behind. Or have we? Because the world is warming, and with that warmth comes a kind of forgetting, not just of temperatures and shorelines, but of what it means to live in rhythm with a planet that never holds still. We have built a civilization, astonishing in scale, on the assumption of stability, predictable seasons, reliable rivers, coasts that stay where they are, forests that regrow, mountains that behave. But the Ice Age whispers something different. It reminds us that change is not a glitch. It's the system. It shows us that Earth's climate has always been dynamic, veering between extremes, oscillating with the sun's angle, volcanic spasms, the stirrings of ocean currents. The last 12,000 years, the Holocene, have been unusually calm, and in that calm we took root. Farming flourished, cities rose, language spread, writing, trade, religion, philosophy, all of it, balanced on the razor-thin edge of a brief interglacial pause, but now we're shifting that balance ourselves, and fast. In just a few centuries, our geological blink, we've pulled millions of years of carbon from the ground and sent it skyward. We've doubled, tripled, accelerated the atmospheric chemistry that once took millennia to change. Glaciers are retreating at a pace unseen since the most violent warming pulses at the end of the last ice age. But this time, not triggered by orbit or tilt or sunspots. This time, it's us. And that realization lands like a quiet exhale. Because we are not just animals shaped by climate, we are now shapers of climate. We hold, perhaps for the first time in Earth's history, the tools to understand planetary systems, and the power to alter them. and that brings with it a question not of knowledge, but of wisdom. What will we do with this responsibility? It's tempting, in the face of such scale, to retreat into despair, to see melting ice and rising seas and vanishing species and feel small, powerless, late to the story. But the Ice Age teaches a different lesson. It tells of resilience, of slow, steady transformation, of systems pushed to the brink that found a way forward, not by resisting change, but by learning to flow with it. It reminds us that what survives is not the strongest, but the most adaptable. The mammoth, for all its grandeur, is gone, but the tiny vole, the Arctic fox, the grasses beneath the snow, they remain, not because they were mighty, but because they moved with the rhythm of the planet. So too did we. For hundreds of thousands of years, humans lived as part of that rhythm. We read the sky, we watched the rivers, we listened for the first crack of spring ice. And in doing so, we built cultures that were intimate with change. That knowledge is not lost. It's buried, perhaps, beneath asphalt and algorithm. But it's not gone. It lives in indigenous science. The Inuit understanding of sea ice, the Aboriginal tracking of seasonal fire, the Andean calendars tied to glaciers. It lives in stories of great floods, long winters, wandering ancestors, forgotten islands. It lives in the soil, in the tree rings, in the silence between storms. And now, as we face a warming future, those memories may become lifelines. Because the modern parallels are not subtle. The melting permafrost is releasing not only methane, but microbes. The retreat of glaciers threatens fresh water supplies for millions. The shifting jet stream alters rainfall patterns, drying fields in some places, flooding others. Coastal cities face rising tides. Coral reefs bleach. Insects shift ranges. Disease patterns follow them. This isn't hypothetical. It's here. And yet, there is a paradox. We are more powerful, more connected, and more informed than at any point in history. We can model climate with astonishing accuracy. We can track carbon from tailpipe to tree. We can deploy satellites that monitor Earth's energy balance from orbit. We can, if we choose, act, not from panic, but from knowledge, from humility, from memory. Because if the Ice Age has a final lesson to give, it's this: the Earth changes, and so can we. In fact, we already have. We've learned to grow food in deserts, to build floating farms, to sequester carbon in stone, to restore mangroves, to mimic the way forests breathe, to build cities that cool themselves. These are not dreams, they are real, present, unfolding. Adaptation is not retreat. It's resilience in motion. Mitigation is not surrender. It's a rebalancing act, remembering that our atmosphere is not a garbage bin, but a breathing layer, thin as frost, that wraps our world. And hope? Hope is not a mood, it's a practice. It is found in river restoration in Kenya, in community farming in Bangladesh, in Arctic youth councils, in climate law, in rewilded beaver ponds, in classrooms learning to read ice cores like scripture. It's in the scientists who stay up late analysing stalagmites, and in the elders who remember when the rains used to come in June. It's in anyone who listens, to data, to history, to the land, and then chooses to care. Because caring, in a world shaped by ice, is an act of survival. And the Earth, for all its indifference, has always responded to life that chooses to persist. So maybe we are not late to the story. Maybe we are the next chapter, and what we write will be remembered in the isotopes, in the silt, in the warmth or silence of centuries yet to come. Because the Earth in the end always remembers. It remembers the footfall of mammoths, the flight of birds, the spread of grass. It remembers the first fire lit in a glacier's shadow. And it will remember us. What we burned, what we planted, what we let go, what we chose to save. The Ice Age was not the end. It was a beginning. And now so is this. And so, here we are, From frozen plains to warming cities, from mammoths to molecules, from ancient dust to distant futures, we've wandered through a story that's still unfolding. The Ice Age is not just behind us, it's beneath us, inside us, around us, in the shape of valleys, in the tilt of our DNA, in the rhythms of our breath. And if you've made it this far, maybe the story spoke to something in you, some soft recognition, some quiet awe. If you found comfort in this slow unravelling of time, or if it gave you something to carry into your evening, a new curiosity or just a calmer mind, I'd love for you to like this video, maybe subscribe if you haven't already,